Number 4 was the question that I had you skip when we first did this. It says the rational function h is expressed as the quotient of two polynomial functions, f and g, by h of x equals f over g of x. The function f is given by, and then it gives you that full thing, if the graph of h has a slant asymptote of y equals 2x minus 1, which of the following describes g? So a couple of important things to pay attention to. One is it goes f over g, so it is this guy over g of x. Which means if I just start with the fact that it has a slant asymptote, what would the exponent have to be in the bottom? 1 less than the top. So if the top is 3, what has to be the exponent in the bottom? 2. So already I can narrow it down to A and B. Does that make sense? Yes, for everybody? Okay. Now it says it has a leading coefficient. So if I were to put out here 6, if it was just 6x to the third, blah, 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 and I had something out here, what would result in a 2x minus 1? What would I have to multiply 2 by to get to 6? 3. That's where your leading coefficient comes into play. So A should have been the answer there, okay? So if the quiz and also test might ask you straight up, what is the slant asymptote? But then the AP level questions will be something like this, okay? Questions on that? Yeah.
Is there a test going to be made up of AP level?
So from the numerator, I got my zeros, right? X equals -2, and it bounces. From the denominator, I got my asymptotes. This was factored x squared plus 4x plus 4x, x plus 2, x plus 2. And that's where that came from. Then so if I actually just started with that, vertical asymptote at -3, and positive 3, 1, 2, 3, 4. Okay, 0 at 0, 0 at -2, and it has to bounce off this point. So whether it's going to be whether it's below it or above it, I don't know yet, but I know it has to bounce. Then I obviously, if you look at your answer choices, it involves more than just the in-between. So I have to see what's happening on the outsides of these as well. So if I plugged in, I think I plugged in -4, I plugged in -1, I plugged in 1, I plugged in maybe +4, kind of just to see what's happening in those areas. There's also a slant asymptote, so now that we know that, because it's bigger, I would get x to the third plus 4x squared plus 4x plus 0 divided by x squared plus, I wrote on top of it, it's a -9, right? Yeah, -9. Which means there's a x squared plus 0x. So I'd have to multiply by x. Plus 4. The rest doesn't even matter. So now I know I have a 1, 2, 3, 4 slant asymptote that's happening here. Remember, your middle can cross through a slant asymptote. The outsides helps you with those corners, though. So if I took and plugged in those individual points, I would know the behavior above and below. You also could use your end behavior test, which is look at the exponent that's the biggest, plug in your infinity. If I plug in negative infinity, I get negative infinity, which is why the graph will probably look like that. And if I plug in positive infinity, I get positive infinity, which is why the graph would probably look like that. But it could also go on the other corners and still be that same end behavior, which is why I plugged in points. So I plugged in -1. I wrote all over it. -1 to the third plus 4, -1 squared plus 4, -1 over -1 squared minus 9. And I got -1 plus 4 minus 4 over 1 minus 9. -1 over -8, which is 1/8. So I'm above the x-axis at that point. Now I know it has to bounce here, which means it's going to come down, it's going to bounce, and then it's going to hit that. And then it has to cross through at 0 because it can't bounce. So I know it's going to come below my graph at some point there. I could also plug in positive 1 and see what happens. I'd get 1 plus 4 over negative 8. So 9 over negative 8, and that confirms I'm below the x-axis there. So now I know this part is above, which was from negative 3 to 0, and that's already this one alone. That's the only one that's left. If I plugged in a point on the right here, if I plugged in positive 4, it would have been up high, which would go with my initial up, that top right corner. And if I plug in negative 4, it would be down low. It would actually be below it, which would be consistent with that same point. Yeah. The slant makes the ends go in those little corners. So slant would either cause the corners to be here and here, which would mean you'd have another 0. So you could kind of rule that out because you'd have another 0 there. Or it goes top right, bottom left, which is what this one ended up doing. The middle, it can cross through it. Yeah. If you don't know, yeah, like if you can use your end behavior there, but it didn't really, like, the end behavior, the fact that it didn't have a 0 made me know that it's not going to cross through here. That's helpful. But the in between, I would say you're plugging in points. Yep. All right. Let's go. I'm going to go over 1.8, but you're still working on the rest. Like, just because you finished 1.8 doesn't mean you're done, people. So 1.8 said the rational function is given by, for what values of x does r of x equal 0? This would be, like, in my opinion, an easy gimme question if you know what you're doing, because all you have to do is use your calculator, right? You could literally graph your whole function and then find where it crosses the x-axis. That's one way to do it. The other way is to solve your numerator. Now, I can't factor that numerator, so how would I have had to solve it? The long way around would be to, like, because it's not quadratic. You can't use quadratic formula, right? The long way around would have to find a rational 0, which there are none. So that's why they give you the calculator. Like, usually if they're giving you the calculator, it's because it can't be solved any other way. So that I literally just graphed it and then found where it crossed the x-axis. So knowing what this means and knowing how to use your calculator should have gotten you to answer that one. Number 2, it said the rational function g is given by, and then it gives you the whole thing, for what input values of g are the output values of g equal to 0. So this is where, again, now we assume we always check for a whole. Like, you assume any rational function, the very first thing you do is check for a whole. And there is, if I actually factor out the numerator, I would have gotten x times x plus 3, and then x minus 5 times x plus 1. And the x plus 3 cancels out. So now you're left with x equals 0, x minus 5 equals 0, and x plus 1 equals 0, which is 0, 5, and negative 1, which was B.